We discussed continuity in our last video, and now we're wondering, what is differentiability? Question mark. Well, we've got kind of two informal definitions here. So the first one, let's take a look at that. A differentiable function is a function whose derivative exists at each point in its domain. And as a reminder, a derivative is basically finding the slope of tangent lines. So you're essentially saying that these tangent lines exist and they have a slope that exists. So looking at this picture here, is this function differentiable here? Well, sure, we can draw a slope here, a tangent line here. That slope exists. How about here? Yeah, we can draw a tangent line here. How about here? Sure, here's a tangent line. So this point right here is differentiable. At x equals 0, it's differentiable. But actually, there's no problem with any of this graph. So for each point, if there can be a derivative or a tangent line drawn, then we can say the function is differentiable. The second informal definition says if the derivative of a function is continuous, then the function is differentiable. So the function I'm talking about is f of x, which is this graph right here. We'll call this f of x. And the derivative we'll call f prime of x. Well, if I have f of x equals x squared, my f prime of x, what's the derivative of x squared? It's 2x. So that's the graph that looks like that. I guess I could have made it a little steeper. Okay, so that's your 2x graph. So is this function right here, is 2x continuous? Yeah, it is. So we're saying that f of x, the function f of x, is differentiable. And why does this work? Well, this is essentially saying, hey, if x equals 1, my derivative is 2. In other words, the derivative exists at x equals 1. All right, so what about at x equals 3? Well, that would be this point right here. That's the point 3, negative 6. And so our slope at negative 3, maybe right up here, has a slope of negative 6. In other words, if your derivative is continuous, you are implying that there's a tangent line slope for every single point for f of x. So f of x is differentiable. There are 4 cases when a function is not differentiable, and you can take a guess at some of these, but I'm going to give them to you and make sure you get them down. This first case is a corner. It is not differentiable at x equals 0. Well, why not? Can you draw a tangent line there? That makes no sense. I can't, that's not a tangent line. How about here? Nope, that doesn't work for the other side. So there's no way to draw a tangent line, so there is no derivative at that point, x equals 0, so it is not differentiable at x equals 0. Make sure you know this term, corner. How about a cusp? A cusp is this, almost looks like a seagull, right? So here, again, at x equals 0, there's no tangent line. That doesn't make sense to draw a tangent line there. And so there's a cusp, make sure you know that, and it is not differentiable at x equals 0. However, it is differentiable at 2. You can see you could draw a tangent line there, but it is not differentiable at x equals 0. Then you've got the vertical tangent. In this particular case, at x equals 0, I actually can draw a tangent line. In fact, it would be vertical. But the slope of that is rise over run, which would be some number, but our run would be 0, meaning that our slope of a vertical line is undefined, meaning we don't have a tangent line slope there. So, therefore, we have a discontinuity at x equals 0. In other words, we are not differentiable at x equals 0. Why? Because it's a vertical tangent. The most important one is we are not differentiable when we have a discontinuity. There is no way to draw a tangent line at something like this. That doesn't even make sense. So there's no derivative at this point. So this function is discontinuous. There is a discontinuity at x equals 0. And it's also not differentiable at x equals 0. So this discontinuity is, I think, the most important one. If you have a discontinuity, you cannot be differentiable at that point. I'm going to say that again. If you have a discontinuity, you cannot be differentiable at that point. All right, let's go ahead and try this problem. Determine if the function is continuous at x equals 0. Well, this is a little bit of review from the last video. All we do is just plug that right in, see if we have issues. Well, that's going to give me 0 minus 3 times cosine of 0 minus 1. Well, that gives me negative 3, no big deal. Cosine of 0 is 1. Then don't forget my minus 1. That gives me negative 3 over 0. That is not good. I cannot have a 0 in my denominator. So the function is not continuous. And I do have to say at x equals 0, because it's continuous everywhere else, just not at x equals 0. All right, determine if the function is differentiable. Well, we haven't really established a process for this besides looking at a graph. But what did I say here? I said that if you have a discontinuity, if your function is not continuous, then it is not differentiable. Okay, so because we are not continuous, because f of x is not continuous at x equals 0, then f of x is not differentiable at x equals 0 either. That's key. If you find for A that it's not continuous, then you would of course say for B that it's not differentiable. How about this one? Let's determine if the function is continuous at x equals pi. Well, f of pi, kind of weird to write, is 3 times pi over sine of 2 and then pi. Okay, well 3 pi is 3 pi, but what's sine of 2 pi? Well, here's your graph. Sine of 2 pi is 0. Uh-oh, we can't have a 0 in the denominator, so this is not continuous at x equals pi. All right, B, determine if the function is differentiable at x equals pi. No, it's not, because it is not continuous. If you have a discontinuity, like in this right over here, there's no way that you can have a derivative there. No way you can have a tangent line. So it is not differentiable. In other words, you can't take a derivative at that point. All right, last one. Determine if the function is continuous at x equals 0. F of 0 equals absolute value of 0 equals 0. Yes. Yes, it is. We can plug in. There's no problem. We can even look at the graph, and we can say that the limit as x approaches absolute value of x, when x equals 0, that's 0, and so is the evaluation of f of 0. So that's definitely continuous. Is the function differentiable at x equals 0? That's a big fat no, because it is a corner. There's no way to find a tangent line slope at that point. So let's wrap things up. Which one's true and which one's false? And yes, I think I could ask you this question on a test. Does differentiability, if a function has a derivative at every single point, does it imply continuity? Does it imply that the function is continuous? Well, what did you say? The answer to this is yes. because in order to be differentiable at all those points, it has to be continuous in the first place. Therefore, if you know something is differentiable, it has passed the test of being continuous already. Let's look at this next one. Does continuity imply that your function is differentiable? What do you think about that? Well, if you said no, you are correct. Let's look at this example. This is absolutely continuous. In fact, it's continuous at all values, but it is not differentiable at x equals 0 because of that corner. And so this is a big fat no. Thanks for learning about differentiability. It's been a pleasure. Have a joyous day. Bye.